Yeah, I think it started, right?
Yeah. Okay.
Yeah, I forgot. So do I need to read the question again, or?
Just read the question once more. It will be
Yeah, okay. Yeah, sure. Okay. So three stones are on a number line at given three positions A, B, and C. In every turn, we need to pick a stone at the end point, and that end point would be either lowest or the highest one. And we need to move that to an unoccupied position between those endpoints. Formally, what they're saying is if we have X, Y, and Z positions such that they are in these increasing order, then you need to pick up the stone at either position X or position Z and move that stone to an integer position K such that this K will lie between X and Z, and K shouldn't be equal to Y. And the game will end the moment you can't make any more moves. That is, the stones are in consecutive positions. And when the game ends, what is the minimum and maximum number of moves that you could have made? And just you have to return that as a minimum moves and maximum moves. An example we went through, like A, B, and C is given. So first, this is min, this is max. So you have to move either from this or this. So here 1, 2 are consecutive, third and fourth positions are vacant. So you can move either 5 directly to 4, directly to 3. Then 1 to 3 will be consecutive, or you can move 5 to 4 and 4 to 3. So max moves will be 2 to make it consecutive, and min moves will be 1 from 5 to 3. So 1 and 2 for that. Here they are already sorted. So there is no unoccupied position between any of these positions. So 0, 0. And coming to this, again, this is the min and this is the max B. So here we are moving 1 to 4. This one we are moving to 4 in order to make 3, 4, 5 X consecutive, or we can move 1 to 2 and then to 4 to make 3 to 5. For that, the number of positions will be 2 max position, and for this it will be min. Yeah, so as he said, like I've sorted all the three numbers, and this here I'm just checking if they are all are consecutive. That means there are no unoccupied positions between any two numbers. The minimum number of moves would be 0. Else, if you find gap between any two numbers as greater than 2 between X, Y, and Z, the difference of them, if it is greater than 2, then max move should be 2. Or if there is only one, like 1 and 4, 1 and 3 is there, then 2 will be vacant. For that it will be 1, and then max will be, since we have already sorted it, so first will be X and last will be Z. Difference of those two, and subtracting, you can subtract those first and last move minus 2 and then return the max. This one. Any queries in this implementation part?
Why max step has a -2? I didn't get that.
Yeah, easy. You'll have sorted this one, right? What do you say? Let's say, let's take an example. One thing I mean, you'll agree that first one is at first position. The last one is at fifth position. Okay. So if you get a difference of those two, first minus last, whatever positions you have, and when you move from first to second last, or from first to second position, those two positions we are subtracting from here to get the max one.
Okay. Yeah.
You can break them into two equations, as I said. Z minus Y minus 1 plus Y minus X minus 1. Yeah, you can break it into two equations. Z minus Y minus 1.
Z minus Y minus 1.
1 plus Y minus X minus 1. So left hand side is the moves that Z can make to reach just one step ahead of Y.
Okay.
And the right side is the moves that X can make to one step
move Y
before Y.
Yeah, and this Y will be cancelled.
So these two you can add, and
it's Z minus X minus 2.
Minus
2. Yeah, makes sense.
So this is for the max value, right?
Yeah.
So minimum is very easy, like just to find if they are consecutive or not, and whatever is not consecutive, just keep on adding them. So either it
Adding
will be
them,
0, 1 or 2, right?
2, yeah. Because only 3 numbers are there. If first and last is there, then from first reaching to last 2 steps.
Yeah.
Mhm.
Can we take the example of like 5, 10, and 20? Or
5, 10, sorry,
20.
20. Yeah. So the numbers are not consecutive, and so min
Oh,
steps.
yeah.
Yeah. Then y minus.
So first the minimum. So what will be
Tell
the
the
minimum?
minimum will be 2, I think, here, because the value is greater than 2, right? 10
Mhm.
minus 5,
Yeah.
like
Yeah. So
yeah,
there will be 2. So you have to make 2 moves. You have to move 5 also as well
10,
as 20, right?
20, yeah, exactly.
So that minimum steps will be 2. So the
And
maximum will be like you found out the difference earlier. So 10 minus
z
5.
minus,
Yeah. 10 minus 5 minus 1.
plus
What is that?
your will be,
Yeah, you can do
which
the
one?
addition later. So if you just
Okay.
so this will be 10 minus 5 minus 1 will be 4, right? And 20 minus 10 minus 1.
10, sorry, 20 minus 11 it will be, sorry, 9 it will be,
So 9 plus 4 will be,
13.
yeah. So 9 plus
So
4 will be
max
13.
steps should be
Max
13.
will be
Yeah.
13.
So this is at, yeah, fifth.
Yeah, okay.
Yeah. Yeah. So any queries in this further? Like a time complexity, this, I think this will take in log n. But I think it's, they have given only 3, right? Each time you pick in. We have only, this is fixed x, y, and z. Only 3 it will be, right?
Mhm.
Yeah, it's a
Yeah.
constant space.
Yeah, it is a
Constant.
constant.
Yeah.
Yeah.
Yeah, so it doesn't make much. Yeah. Okay, let's proceed to next. Any queries in this?
Yeah, let's move. Yeah.
No, no, okay. Find the peak element. Second question. A peak element is an element which is greater than its neighbors. We have been given an array of numbers of which nums of I is not equal to nums of I plus 1. Find a peak element and return its index. You may imagine that nums of minus 1 equal to nums of n, and which is equal to, I mean, they have substituted it with minus infinity. And yeah, numbers array of integers is given. 2 is a 1, 2, 3, 1. So 3 is a peak because they are greater than their neighboring element. And so the index of 3 will be 2. So they have returned 2 over here. And you can have more than one in peak element, and you have to return either of the indices. So your function can return, you can see here 1, 2, this 1, this 2 is greater than its neighboring. So index of this is 1, and 0, 1, 2, 3. If you look at 6, 6 is again greater than 5 and 4. So I've returned either 1 or 5. Yeah, it should give a hint like your solution should be in a logarithmic complexity. So any queries in the question?
So if you are at like the 0th position or the nth minus 1 position, so the either of the endpoints, they are negative infinity. That is what it says in the last sentence,
Negative,
right?
yeah.
Okay.
Minus infinity, yeah.
So if either of these the endpoints, if we check the previous neighbors, okay, and if they are lower than that, then the peaks are those elements, right?
Elements, yeah.
Okay.
Is the value positive only on non-negative value?
They haven't, I think, regarding values, they haven't shared anything.
So let's say if I have only one element and that element is -2, then what is the peak?
That element itself.
-2.
Yeah, because
Yeah.
values of either of the sides are like negative.
Minus
Yeah.
infinity. Hmm.
So that should be -2 is the right.
There was a inconsistent test cases, I think. If you're going like decreasing order, 5, 4, 3, 2, 1, it should be 0, meaning that there's no peak, right? And if it
Yeah.
goes to 1, 2, 3, 4, 5, then 5 is the peak.
Yeah.
Yeah, if
Five
the
should be
Yeah.
the
Five
should be
is the peak, makes sense, right? Because the rightmost is
Left.
negative.
Minus infinity. Yeah. I think somebody in chat.
you may imagine.
But what if it's -2? Then what is the peak? There's no peak.
no, it's still greater than minus infinity. So
Minus 2 is
two is
greater than minus infinity.
Oh, got it. So both sides of the array, let's say, we imagine
Yeah.
they're both minus infinity. Got it. Okay.
Yeah. They mentioned that.
Got it. I saw it. Yeah.
Any approach in this?
ON approach is straightforward.
Yeah.
You can check every element whether it is peak element
Greater
or
than
not.
its neighbors.
Yeah, but logarithm, I don't think so.
Logarithmic should give you a hint regarding binary search.
Binary search, but like
Using recursive binary search, I mean using divide and conquer and then apply binary search.
what are
Because
the
here-
constraints? Does it suggest that like peak would always exist and
It hasn't mentioned anything like that. Find a peak element that is returned.
yeah, at least if all elements are not equal, then there is peak. If they are all equal, then also that's the peak.
So someone is having a question on the chat. He's saying that if the input is 1, 1, 1, 2, 2, 2. So what
Yeah.
would be the peak in that case?
Okay,
There's no peak, I think, in that case.
What is
yeah,
He's saying
Can't
1,
we
1,
say
1,
2 as the peak.
2, 2, 2.
So it looks like, I mean, there's a condition ni numi not equal to numi plus 1, so which means that there is no duplicate.
Yeah. Okay.
duplicates are not there? Yeah, this one.
Means the duplicate are not consecutive. They can be there.
They are not consecutive, but they can be there. Duplicates are there, but they are not consecutive.
So I think we can do it with binary search because if the array is in increasing order or in a decreasing order, then
Yeah.
only the last element or the first element would be the peak.
Yeah, those
Otherwise,
are corner cases, huh?
yeah. Otherwise, we'll anyways we'll get the peak in half if we keep on dividing.
Yeah.
Yeah,
So
till
you're talking about the binary search approach, right?
Yeah, I think logarithmic. we
Yeah,
can
but
only do binary search.
how about the O of n? You said about the O of n, right?
Yeah, O of
so
n
let's
would
go with
be
that. Uh-huh.
yeah. So O of n would be straightforward. We can go through each and every element, check if that element is the peak, and condition for that would be that it is greater than I minus 1 and I plus 1 of that element. So if we are checking for element number I.
So you have to go through each and every array, each and every element of an array.
No, if we find the first one, we can just return. The worst case would be O of n with the
As a brute force way.
yeah.
Okay, but then why it is being shown like, you just compare only the one neighbor, because usually you have to compare both the neighbors to get that value, right?
Yeah, we'll have to compare I minus 1 and I plus 1, both of them.
Before that, we'll append here this side minus infinity and that side plus minus infinity, right? I mean, whatever num is there, n plus 2 the length should be.
Yeah, you can append if like, or logically you can write it in the code that if you are checking for the first element and the left hand side you will always, if does not exist, you can treat it as minus infinity.
Infinity. No.
very frankly, the binary search approach is not very intuitive, right? So even
Yeah,
if they say it is a
but
sorted array, so it is not an easy to just come on the top of your head, right?
No, because of
yeah,
this hint, I mean, I
They
think
mentioned that it should be logarithm, so they are just asking you should actually think in that direction only.
yeah.
Hmm.
I think it's non-intuitive because in binary search we're usually searching for a number, right? And here here we're searching for a number, but in a kind of different way. We kind of compare neighbors, and I don't know.
So we are not applying binary search directly on the entire. I mean, we'll
We
be
divide and conquer. Yeah,
yeah, and then yeah,
yeah.
because directly we can't apply because of the array is not sorted. So this is the approach,
So
it's
even if in
Sure,
binary
go ahead.
search, then how do you know it increasing slope or decreasing slope?
That you don't know. I mean, you
We-
just need to actually find that where the potential solution exists.
Could be.
and the thing is, like, as I'm thinking, like, if either array is either decreasing or increasing, then the corner elements would be the answers. Otherwise, you can, I think, look into any of the halves and you'll get the answer. Maybe it seems like that.
Yeah, I think that makes more sense. Yeah.
But then the worst case still big O of
Yeah.
n.
No. Even in that case, you know that if you're at some particular element, you know that it is like you can always check both the sides, both the adjacent sides, and see whether you should go into the left half and the right half, knowing that your
Yes,
corner
but
cases are either increasing or decreasing.
the worst case, like we see, 1, 1, 1, 2, 2, 2. There's no peak, so we still go big O of
No,
n.
that is not a
No, this is
valid testing.
valid in.
Oh, it's not.
It's not valid. You can have duplicates, but not consecutively.
Oh, okay.
No. So that is why I think you can use binary search over here.
The proof for this applying binary search was said in some one MIT lecture. There is algorithm 606. There they have mentioned how to find peak in a 2D or in a like why binary search works even though it is non-sorted. Well, I haven't gone through that yet, but I'll share the link in the Slack.
Sure. Yeah. No problem.
Why binary search, but in conjunction with divide and conquer, or just binary search?
No, with divide and conquer they are using.
Yeah.
And they have mentioned some more conditions which I'm not recalling as of now.
Yeah, I think you can apply it in anything, and still, like, the worst case it could be O of n, right?
Yeah, worst case it would be O of n.
Yeah.
But
So in your binary search, the condition for your the midpoint. So the way you compare is like whenever you compare, you just find if it is increasing or decreasing, and then only you make the right or left shift, right?
Left, yeah. First, I'm checking if the mid itself is greater than its neighbors. You got the best possible case. Else, if your left part is greater than the mid, then you go to you'll shift to the left part. Else, you go to the right part, mid to J. And these are the corner cases. If single element you have written this, if you have two elements, then whichever of them is greater, return the index of it.
But what if you at a midpoint, but you don't know if increasing or decreasing?
You'll always know because nums of I cannot be like two consecutive numbers cannot be equal. So you'll always go into some side. I think that is why we are getting answer using the binary search.
Okay. Yeah.
Rely on this.
Okay. Yeah.
Yeah. So proceed to next. Or any queries here?
Yeah. Go to the next one.
Okay. So this one, it's like masking the personal information. We are given some personal information string as which may represent either a mail address or a phone number. And following are the rules for that. For mail address, it's like we define a name to be a string of length. Length should be greater than 2, consisting only of lowercase a to z or uppercase a to z. And email address starts with a name followed by a symbol @ followed by a name followed by dot and successively followed by a name. All the email addresses are guaranteed to be valid and in the format of name @ name2 dot name3 within double quotes. To mask an email, all names must be converted to lowercase, all letters, and all the letters should be, all the letters between the first and the last letter of the first name, and they must be replaced by the asterisks. And regarding the phone numbers, the rule is like phone number is a string which would consist of digits 0 to 9, or the characters, these plus, minus, open, close parentheses, and curly braces. Not curly braces, sorry, empty string. And you may assume a phone number to contain digits from 10 to 13 digits, okay? And the last digits make up the local number, while the digits before those make up the country code. Note that the country code is optional and we want to expose only the last 4 digits and mask all other digits. The local number should be formatted and marked as this rule pattern should follow, where 1 represents the exposed digits, and to mask a phone number with country code like this, we write in the form of this one. The plus and the minus sign before the local number should only exist if there is a country code. For example, 12-digit phone number should start with plus, asterisk, and minus this. And extraneous characters like close and open parentheses, as well as the extra dashes or plus signs, should not be part of the above formatting. Should be removed to return the correct mask. So leetcode@leetcode.com. So they follow the rules above. All names are converted to lowercase and letters between first and last. Now the first name is replaced by 5 asterisks. Therefore, this becomes, I mean, it's more about remembering the rules than any queries in this question, in the question.
So in an email, what if the name was only of 1 character, the first name?
We define a name to be a string of at least 2. Length should be
okay.
greater than.
Okay, so it is 2, yeah.
Yeah, it's more of a rule. I mean, so many rules they have.
Mm-hmm.
So if it's 2, then we don't need to mask it, right?
Pardon?
If it's 2 characters, then we don't need to mask it because it only masks between the first character and the last character.
Yeah.
So in this 2 also, you need to actually insert all the 5 characters.
Yeah.
So whatever the length is, we just take the first and last character and insert 5 asterisk characters in between.
Asterisk characters. Yeah. And these are the rules for phone numbers.
Okay, so this is more of an implementation detail.
Yeah, exactly. If you remember the rules, it's good. Nothing as such. Emails have length at least 8. Phone numbers have 10. Yeah. So to dislikes. So any implementation everybody wants to share. Yeah.
Mine is kind of longer.
Yeah, sure. Share it. I'll stop you share.
In Python, you can always write.
These functions are taken care of.
Yeah.
We'll split.
Yeah.
I think yours in C++. Yeah. You want to share?
Yeah, he's sharing things.
Okay.
Sure.
Yeah. Okay, I'll stop. Let me stop.
Can you see it?
Yeah, sure.
All right. So I mean, I read through the requirements, and so if first I'm checking if it's valid email, and I split it. So by splitting it with @ if the length is 1, then it's not a valid email. And then convert it to lowercase, and then I split second part with a dot, and if the length is 1, it's still not a valid, return empty string. and then we convert both sides with lowercase and return it. Now, if from step 1 we return empty string, I'm sorry, null, I return null. So if it's null, then check if it's a valid phone. So I kind of changed the logic here, but here, can you see this, or should I make it larger?
Yeah, you can increase font size a bit.
Yeah.
Yeah,
Yeah. Yeah. So here,
make it more larger actually.
say it again.
Yeah.
Yeah, you have to increase font size. Zoom it. Yeah.
Yeah. Is it good now? I think.
Yeah, it's fine.
Yeah, it's fine.
Cool. So here I check first the string is null or it's empty, return null. Otherwise, I get masked email from this method. So first I split with @. If its length is 1, return null. Then I split by dot, the second part. If the length is 1, return null, meaning that there's no dot. So if I split, so I take the lowercase for each of the parts, and I build the string, and then I return it. I build the string, the name string, which is the first character of the split, the 5 stars, and then the last, and then I return the name and the dot split. I mean the name and then domain and
the last one,
.com, yeah, identifier. So and then if this returns null, then we are checking if it's masked email. If it's not, then it returns the masked email. But if the masked email is not, then we go check masked phone number, create a string builder. So in order not to generate strings all the time, so create a char array from the string, and then for each of the strings, I go backwards. If the character is digit, then first I check if how can I explain it this better? So first we need the last 4 digits of the number that is given. So that's why if the string builder has less than 5 characters, I append the character as is. So I mean I append the digit as is. So, but think of it this way: it's in reverse order. I'll tell you. Let me see if I can explain why we took a reverse order. It was easier to kind of comprehend what is need to be masked and what needs not to be masked, and also get rid of the rest of the characters instead of just deleting. So when it's less than 5, then we append the number. Otherwise, we append a star. When the SB length is 4, or when it's 8, or when it's 12, then that's when we append the dash. If you can see if the format of the problem was that, let me share that too. The problem. Masking. There it is. Let me just.
We'll have to stop this screen share and then do that.
Yeah.
Yeah.
Okay, so so as you can see here, dash is on the when the length is 4, and then when the length is 3 plus 4 7 plus 1 8 or 12, that's when we add dash to it. And then once we do, once this finishes, like all the characters, then if the length is greater than 12, then we append a plus. Otherwise, if the length is equal to 12, we don't have a plus in front of the phone number, and then we just reverse it, and that's how we get to let's say this number. So we go 1 by 1 backwards. Whenever we find a digit, when the string is 4, then we start masking 6, and then 5, 4, etc. So yeah, after that, That's it.
And then you reverse the string for the phone
And then
number.
yes,
Okay.
I've reversed the string. Yes.
Hmm.
I mean, it's not the fastest.
Hmm.
So
No, but it's a complete
comprehensible.
requirement actually. I mean, it's very complex. Yeah. So, but I like the way you actually split the email and the phone using the add, because I was trying to do with the numbers, and then I started comparing the last number and said, okay, if it's an email or phone number, but sometimes the last number also there is a character dash non-numeric character, and that was
Yeah.
a problem for me in some cases. So add is the best thing to do. Yeah.
Yeah. Cool. Yeah, I don't think it's the fastest solution. I mean, it's 26% runtime.
Choose for 2.5. Click here 2.5. What kind of fast?
2.5. This one.
Yeah. Open. What Java? It's
I think only you could avoid using a inverse, reversing the string in the.
That takes time.
Maybe, I'm not sure though. Yeah, then slightly there might be a chance of actually increasing your efficiency there a bit.
Yeah.
Yeah.
But then we still have to kind of, if we go in the other way, if we go not backwards, but if we go forwards, then you don't know. You have to pass one time to delete the characters, like this character and then this character.
Oh, yeah. You don't know
And then
what is the
you don't
number
know
of.
when
Okay. Yeah.
to add. I mean, at least I don't see it. If somebody sees it, he can explain.
Yeah, that's true. Anyway, you have to traverse twice.
Yes.
yeah.
Yeah, that's good.
Yeah.
I think maybe because of the split too. I think the string split, it takes time. And it also takes memory to build the array.
Okay. So I think maybe a better way is to kind of we can binary search the at, and we find the index, and then maybe we can iterate through that index while we actually build our name, and also we can start another one from the index on to just kind of substring it from the from at to the end and lowercase and return. Maybe, I don't know, maybe that's just an idea.
Yeah. So actually in an interview, getting all the requirements cleared before implementing the code and as well as understanding them very well, that is the key of the whole problem, right?
Yeah.
And that is very important. Yeah.
Or maybe I heard that, I mean, the companies actually take interview, one interview to check your algorithm data structure knowledge, and another is to check your programming knowledge.
Oh, yeah.
So and both interview has different data point. So maybe that kind of question that lengthy to check your programming knowledge.
Patience level.
Yeah.
Patience.
Yeah.
Like the previous question we just solved that is for you can say that to check your algorithmic skill, and this one because it's lengthy but to check your expertise in your programming, whatever language you are picking.
Yeah.
So all the details should be very well actually written, implemented on the whiteboard or wherever. Yeah.
Yeah.
Yep. Good.
Yeah.
Do you guys sometimes apply design patterns to these questions?
Regular what do you do?
Design patterns.
Yeah, I mean, if that kind of problem is asked in the interview, so there is no harm to use those to show your expertise.
Yeah.
I think using design pattern in here to make the code more. It takes more time to write the
It
code.
takes, yes, but I mean, it's a good practice actually. Eventually, it will take time. Yeah, I've realized every time I try to apply some design pattern to these questions, even though like the solution is straightforward, it still take more time than actually writing just a method.
But at least it's good to do that so you understand how design patterns are, so
Yeah.
yeah.
I read
So Vishwa,
somewhere that, I mean, this kind of question where they want to check your programming skills, so they evaluate you from how actually your code is easy to readable, easy to maintainable or not. So they evaluate from that point of view.
Oh, okay.
Yeah.
Yeah.
Good to know that. Yeah.
Yeah.
Let me see if I can find one of the problems that we had before. I try to apply a design pattern to it. Let me see if I can find it.
I don't think we can use design pattern lead code like given the time frame is like very less. I don't think we can use there, and we are not doing like multiple classes and stuff, right? So it's just like one class. So I don't think it's necessary. That's my opinion.
Especially where you have to write lengthy code. So if you break up your code in small functions, so definitely you will get the plus in your interview.
Yeah, definitely.
Instead of writing a 50 line of single function, you break up with small function, just a couple of lines. So that will help you.
Yeah, I think.
And even for interviewer, that will be easy to follow.
Yeah.
Yeah. Yeah. So.
So, Martin, are you looking for that problem?
Yeah. I think I found.
Okay.
There it is. Okay. I'll share my screen. Can you see it? All right. So this one was a couple of days ago when we had to do the binary tree in order traversal. So I try to solve it in both ways, iterative and recursive.
Mm-hmm.
So as you can see, I created an interface here, traversal, and which is a function in order traversal, kicks the node and has a result list. So from this interface, I implemented in two classes, which is traversal recursive and iterative. And then I just overridden the method, and then I implemented the method itself. And then in the creation of the solution, I selected the traversal. So in here, it will be instead of creating new, if I had a chance to pass it to the constructor, it's going to be outside handled what kind of traversal you want. So it will be the design would be either what was it? What was the name of that? Of either factory or not sure, but yeah. So the
You say
paint.
the factory pattern.
The
Okay.
factory.
Yeah, I think it was. It can be a factory pattern. To actually choose. So you have a factory, for example, it's going to be a traversal factory, and then to have a method that will actually create inside what kind of traversal it is. And here you're going to just use the factory to to get the the desired instance of this.
Dimension, okay.
Yeah. Yeah. So yeah, this is one. It would be something like this. So instead of this, actually it can be factory. And this get traversal will be will return the instance of any of these, so that we can actually replace it instead of changing code. Yeah. Yeah. So that was.
Yeah.
One. You have any questions on this, or?
Yeah, that's a good way to try and just understand them. Yeah, that's good.
Okay. Cool.
Yeah, so shall we stop recording?
Oh, Anshu already said create a factory there. Also consider writing dependency.
Oh, did Shashank share his solution?
Yeah, sure. Yeah, so I'm first checking if that at the rate is present in your string. Then I'll split it depending on this as a splitter into, and then convert them to the lower letters. So I'll have two parts, sub part 1 and sub part 2. So the according to the rule, I'll insert this pattern between the first and the last part, and I'll return sub 1 plus at the rate whatever sub 2 is there. Else, if you find that there is a number, then for whatever symbols, if any of the symbols you get like this, like plus, minus, or open or close, you replace them with the empty string. And you can see -4 because there I think some rule was there.
So the last 4 digits of the phone, right?
Yeah, last 4. Yeah, this. So for the last 4, it won't do anything. And just some checking if it is if the character is a digit. For every character in the string, it will sum them up digits, and if it is equal to 10, you return this. Else you return digits minus 10, and this what is it, plus r, whatever pattern this one. Yeah, plus r. Code is increased because of using all these functions, replace, split, or the best, but like you can picking just by 0 and -1, because of which it becomes shortened. But I think in queries in this one.
What was this? Digits is equal to sum of digit s digit.
They are checking if for every character in the string, if it is a digit, then we are summing them up.
Oh, but was it said that we have to sum up? I mean, I didn't.
Yeah, I think somewhere it was mentioned. Code about it. I think it was.
Your code got modified there for some reasons.
Yeah, I think this is digit. No, this is a function. C dot is is digit. I think this was right.
Yeah, something like that. Yeah.
For every character in the string, and you check if it is a digit, you sum them up.
Maybe you just need the count, right? The number of digits what you have, because you have to compare whether they are more than 10.
Yeah, I think it was count.
It's only
If
the
there are more
count.
than
Oh,
10,
Yeah.
if there are more than
Um,
10, I think it just adds
then it
stars
might.
and nothing else.
Right. So in the
Okay.
last line, he's doing it, right? So the digits minus 10, that is what the country code is. So, and then he's multiplying with the asterisk character there.
Hmm.
For every character in digit, p dot is digit, and you have to take. Hmm. I think something I got modified.
Yeah. Maybe when you're explaining at that time, it got messed up. Yeah.
Yeah. Second.
You can retrieve the last submission easily.
Yeah, you can go.
Yeah, we are checking for every character in the string. We are checking whether it is a digit and then summing them. If that is equal to 10, then we'll return this. RV else, you have to follow this pattern minus 10.
So that is what is the count, right? When you are saying a sum, you are checking if there is a digit. So that will be 1, and then you are adding those ones, and then you are getting the count of how many digits you have in the digits variable, right?
Yeah. How many digits are there?
Yeah.
Mhm.
That's
Yeah,
okay.
it makes sense now.
Yeah. I think it got modified, but
Yeah.
okay. No. Yeah.
Yeah. Okay. Yeah. You'll have to stop the
Oh.
recording.
No.
Yeah. Thank you.
Yeah.